Welcome to all. Today we discuss the topic number system. Before we go to number system, let us briefly describe two types, numbers and numerals. What are numbers? Numbers are mathematical objects used to count, measure or label. So naturally a doubt will come, what is mathematical objects? Mathematical objects are abstract concepts in mathematics. Again a doubt will come, what is abstract concepts? Abstract concepts are ideas that people can understand, which has no physical form. Okay, that is numbers. The demand of numbers arises from the need to count, measure, label, etc. Those are numbers. Next we will come to numerals. What are numerals? The numbers can be represented by symbols. That symbols are called numerals. For example, 5 is a numeral. This one, 5 is a numeral to represent the number, abstract concept, number 5. 2 is a numeral to represent the number 2. Unfortunately, we cannot remember large number of numerals because numbers are infinite. So what we will do? We will organize these numerals in a particular way to represent all the numbers. That organization is called numeral system. Egyptians invented first numeral system followed by Romans. The Roman numerals are used until the widespread use of Hindu-Arabic numeral system. Now we use the Hindu-Arabic numeral system. It has only 10 numerals, so its base is 10. Now we will study about number system. Our topic, number system. What is a number system? Number system is a set of numbers along with some arithmetic operation we define on them. Now we will look what are the set of numbers. The set of natural numbers, the set of whole numbers, the set of integers, rational numbers, irrational numbers. These are the sets. We will describe one by one in detail. In order to understand this one set of natural numbers, we adopt a tool, a number line. You have already studied this one number line in earlier classes. What's a number line? Number line is a straight line with numbers placed at equal intervals along its length. So this is the number line. Do you know who is credited with the invention of this number line? It's John Lewis. An English mathematician is credited with the invention of this number line. That is in equal intervals. It's marked and numbers are marked on these equal intervals. What's its use? With this number line, we can easily compare two numbers. We can perform addition, multiplication, subtraction very easily with the help of these number lines. You have already studied all these things in earlier classes. So we adopt this one number line to study number system. It's very quite easy. I have already told you that the number system is a set of numbers along with some operations we performed on it. Now we will look each set of numbers one by one. For that I will use this one block diagram and number line I draw on bottom of it. First set of natural numbers. It is denoted by the letter n. Set of natural number is a set of counting numbers. 1, 2, 3, 4, etc. The counting numbers. It is denoted by the letter n. The next, whole number. The set of whole number is union of the set of natural number along with 0. It is called whole number. It is represented by the letter W. Do you know the history of this one 0? The invention of the 0 is credited to Brahmastupa Siddhanta, the famous work of Brahmagupta, an Indian mathematician, in 628 AD. Before that 0 was in use, but it is used only as a placeholder, just like Egyptians, and lack of quantity as Romans. Brahmasthupa Siddhanta gives 0 as a number with its own right, and it mentioned operation of 0, just like as other numbers. So 0 along with the natural numbers forms the whole number. Then come integers. It is represented by the letter Z, the first letter of a German word Zellen, that means to count. That is set of whole numbers along with the negatives of the counting number. Set of whole numbers along with the negative of the counting numbers. It constitutes the integers. So all natural numbers are whole numbers. All whole numbers are integers. The reverse is not true. All integers are not natural numbers, rational numbers. Numbers of the form P by Q. Where P and Q are integers, Q is not equal to 0. It is represented by the letter Q. We can easily represent numbers 1, 2, 3, 4, etc. in the form P by Q. For example, 3 is written as 3 by 1. It's a rational number. 1 by 2, it is a rational number. We can represent 1 by 2 in this number line also. 1 by 2 will come between 0 and 1. We have already studied in the earlier classes. So, this part is over. Then there are some numbers that can't be written in the form of P by Q. That numbers are called irrational numbers. Example, root 2. Root 2 is called the Pythagoras constant. Root 2 is called the Pythagoras constants. It is irrational numbers. That's numbers we can't be written in the form of P by Q. Why it is not possible to return P by Q, I will discuss in the next section. So the discovery of this irrational number is a quite interesting story. The mention about this on irrational numbers dates back to Indian history. In Sulabh Sutra there was a mention about this on irrational number, but it was not in the form of irrational number. The first proof of irrational numbers given by Hippasus, a Pythagorean, in 5th century BC. Like other art forms of science, mathematics is also a science of numbers. All form of science is continuously changing. Likewise, mathematics is also changing. But these changes are not always welcome, because these changes may contradict the existing belief. The existing belief may be wrong. The Pythagorean belief that all numbers can be represented in the form of ratio P by Q, they have no cofactor except 1. But Hippasus discovered that there are some numbers that can't be written in the form of P by Q, but it contradicts the existing belief. It was shocked by the Pythagoreans, and it is supposed to believe that the Hippasus was drowned at sea as a punishment, but there is no historic evidence about that things. Okay, that's about irrational numbers. So the collection of these rational numbers and irrational number together forms the real numbers. It is denoted by the letter R, represented by the letter R. A real number is either rational or irrational. The name real is first called by René Descartes, a mathematician, to distinguish as real roots of a polynomial equation, which has also imaginary roots. We can discuss all these things in the polynomial part. We can also represent every real number to a unique point on a number line. In other words, we can also say that every point on a number line can be represented by a unique real number. There is a one-to-one relationship between real numbers and the points on the number line. Some textbook it is given that is why it is called as a real number. Okay. Next, we will see how we can represent irrational numbers on the number line. That is, we already know that how to represent rational numbers on the number line. Next, we will see how we can represent irrational numbers on the number line.